Buon pomeriggio a tutti e bentornati a
Good afternoon. Welcome to the afternoon session of a Mix Salotto. After this super rich panel this morning, we are ready to resume afternoon session. So the afternoon will be one of a kind as we've helped you to help us shape the program of the day. You might remember that back in June we launched a survey and we were asking amongst the 7 key topics which would be the top 3 that you would have preferred. The most voted, the 3 most voted, are those that we deep dived into in our program today. And we've actually gathered also over 20 names from those of you who have helped us shape the program for this afternoon. So we have prepared 3 program committees that have defined the program of the afternoon. Now, the 3 top most voted topics were routing and network security, followed by national cloud, and live content delivery will close the 3rd and last session. At the end of the afternoon, we will ask you to vote your favorite session amongst the 3. And we will also recognize those of you users who have been more active on Swipe Card platform, both remotely connected as well as attending in person. Now, I won't take any more of your time. And the first session is about to start and is going to be around network routing and network security. Program committee is made by Antonio Prado, Alfredo, Giordano, Simone, Dore. I'm very thankful to all of you for supporting us in this activity. Antonio has also welcomed our invite to moderate the session. So indeed, Antonio will introduce the speakers and we'll start the first panel of the afternoon session. Good afternoon and thank you. I do have some notes with me as I'm trying to do things the best way I can. Well, first and foremost, as a first moderator for the afternoon session, I'd love to thank Mix for this beautiful event that has been very much organized in an impeccable manner. Thank you so much for Lotta and Morandini and Cipriani. Thank you so much for your patience. I'm also very thankful to my colleagues who have worked with me, Simone, Dore, and Alfredo Giordano. Now, let's deep dive into today's conversation. So after the panel from this morning, we heard about cybersecurity. It has played a crucial role indeed in the morning. Now we're about to actually speak through routing security incidents. We do know that incidents do happen on the internet as well. Well, thank goodness outcomes tend to be not as bad as car crashes or similar. Our community has one common goal to inform and to raise awareness amongst the operators around the need and importance of the routing security. So this is why we have considered for this session to actually talk through a pathway, kind of a journey that would be consistent with my assumptions. So we're starting from the examinations of some of the incidents that have occurred on the internet over the last few years. And perhaps is it perhaps something you're familiar with already, but nonetheless we'll talk through this. So Luca Sani will start from Catchpoint, and then we will hear from Tiziano Tofoni on how to mitigate, and then Sriram, Kotikalapudi. He's remotely connecting from Washington. He will tell us about what are the new emerging technologies when it comes to routing security. Well, in other words, what are the novelties that operators from the internet industry should know about? So I will leave then some final minutes for interaction. Well, hopefully it will all run smoothly.
Da ora che potranno essere poste.
Of course, feel free to submit your questions and comments on the platform. You can also submit your questions remotely or by show of hand here in the room, and you'll be given a microphone. So I'll stop here, and I would invite Luca Sani to speak through these incidents that might happen on the internet. Thank you.
Buonasera a tutti.
Good afternoon, everyone. My name is Luca Sani from Catchpoint. I have prepared this presentation with Alessandro Trota, my colleague. We'll be talking through incidents when it comes to routing BGP, especially focusing on what happened recently. First and foremost, I'd love to thank MEX and Program Committee for allowing me to take part into this event. Now, the incidents that we're going to be talking through may be categorized in two big clusters, so the hijacks and leaks. Now, before we see together in details what it is all about, I'd love to draw your attention on the frequency of these events. These are numbers that we captured from a website which is showing a full list of incidents in BGP stream. As you can see, every single month throughout the past year, tens of incidents have occurred, and this capturing was happening mid-November. So this is why you see a smaller number in November. So what is this due to? Well, BGP, as it has been said by the authors as well, was not designed focusing on security, especially security the way we mean it today. So the protocol does not have any intrinsic components so that it can prevent such incidents. Now, irrespective of these incidents being intentional, so either they are truly incidents or they are attacks, we'll just call them hijack or leaks. Let's start from a prefix hijack. It happens when an autonomous system originates a prefix that has not been allocated to it. If we take the simple internet, we have 5 autonomous systems. Number 5 is originating a P which belongs to root 4. So it is actually sending a message that is containing a certain prefix in its own, but a different system. And then, of course, it just follows the rules of a BGP protocol. So those who are proximate, they might accept it as a message, receive it as a preferred route, preferring the autonomous system number versus path. So AS3, AS1 accept the route from AS5, and the consequence is that the traffic AS1, AS3 to P will go from 5 as opposed to 4. Now, the final destination, it depends on how intentional the attack is. If the hijack is an incident, then the traffic will be dropped because there won't be any service actually paying attention. Or otherwise, the attacker might actually go for some phishing attacks, and he might actually customize that very service to his bad intentions. A leak happens when there is a propagation of a BGP announcement beyond their intended scope, usually as per commercial agreement. So if we take a peer-to-peer, at that point, if there is a propagation of a route from a peer to a different provider, then what we come up with is that we have a leak. So the two cases are here shown on the slides. Back to the internet made out of 5 AS, we have AS5 propagating route towards P received from 4 to 3. AS3 is accepting this routing and will propagate to the rest of the internet. And now AS3 is provider of AS5, and the consequence here is that from AS3 to P will go through AS5 before it goes to 4. So there will be a degradation of performance because AS5 is actually making transit for a traffic that should not be there amongst the two providers, more specifically in this case. Now, let's take a look at two real case examples of leaks and hijacks that have happened recently. The first one is the Cloudflare. Now, amongst the networks being involved here, Cloudflare was there as well, but we will see that there were way more than that. To talk through this, we'll focus on one in specific, that is the 104.26/20, and then the internet, US internet service provider. And what happened on June 24, 19, DQE Communications announced that there would be specific rules to reach out to bar 20, which is usually being announced by Cloudflare. The routes have been received, and they were announced to Verizon, another provider that has accepted and propagated to their peers, Tier 1 and Verizon customers. So formally, the leak happened inside DQE Technologies from a provider to Next, but it is also true to say that towards bar 20 should not have been propagated by DQE, and perhaps this is due to a misconfiguration happening within DQE. So the autonomous system path that were observed were under the shape of Verizon, CenturyLink, and Cloudflare. So there has been a degradation of performances in all services being provided by Cloudflare. Now, what was the involvement? Well, on top of Cloudflare, there were more. And actually, the slide here shows you the percentage of peers that were collected to that route, and they have seen at least one network being affected by leak. So most of peers have received one network. Some have received none. Perhaps they were protected by peer lock or similar. Now, if we expand here the analysis, as you may see on this slide, well, the number of networks affected reached out to 65,000, and the number of AS involved were 4,500. Well, thank goodness not all the peers had the same number of networks affected. On the right-hand side, these are the affected networks, number of origins on the left-hand side. Only 10% of peer has actually observed more than 800 networks affected. So there was some sort of protection there. Now, broadly speaking, more origins were being infected on top of Cloudflare. Well, let's say Cloudflare, banks, and others. More than 4,000 ASES involved, and there's a list here on the left-hand side, and it shows you the time period when this was happening. Hijack, September this year, so recently happened. Spectrum is a provider of services in the United States, again. And more specifically, the service that was affected by hijack was the cable television distribution. We have picked this example, although it is involving not a very big player, but still this has affected some additional peers as well, including MIX to some extent. So what happened? On the afternoon of September 7 this year, KHS, a customer of Spectrum, announced 449 of the 690 networks originated by Spectrum. These announces were being welcomed by Spectrum, and they were propagated to its peers. And this is what happened. You see, these are the route collectors capturing. Perhaps the routes were incidentally originated by Spectrum itself, but we don't know. So the routes that were originated, they were very similar to their own, and of course it did provoke a major degradation of performances and a malfunctioning of the service. So this hijack was being captured also by peer, including Reiss RRC10. And the table here shows you the number of networks being affected during the hijack. You can tell a major difference amongst some peers announcing the 449 networks altogether, and some peers actually announced only 18 networks. And this difference can be explained because out of the 449, 431 were RPKI signed. So they were only signing those letters, those networks that were not being protected. Those who were announcing the 449, it means that they had no protection whatsoever. If we broaden up the spectrum, so we do not just consider the peers connected, but also all the AS being impacted by the hijack, we do also see some well-known routes that allow the 449 networks, while others, they were only allowing 18 to transit. There are some peers and AS that have perhaps declared 19, for instance, and it would be interesting to know why. Perhaps they were having a software for validation purposes that would differ from others, or something else happened. We don't know. These are just two of the examples of the many incidents that happened recently. One last piece of information I'd love to share. These incidents are not just including large autonomous systems from a user standpoint, but also small ones. If we compare BGP stream data with AS rank, we can tell that the AS victims of hijack and leak, they can be either large players or small players in terms of customer call. So the bottom line is that there's no autonomous system that cannot run away from incidents, either voluntary or non-voluntary. What is the conclusion here? Well, perhaps there are two mechanisms in place for us to prevent this incident. Well, there are, of course, some prevention mechanisms, which you'll be hearing about in the next session. And there's also some monitoring mechanisms that should allow to monitor all of those incidents that, for some reasons, cannot be protected, either because mechanisms are not accurate or because the incidents are done on purpose. So this is over from my side. So I leave the floor to the next speaker.
Grazie, Luca.
Thank you, Luca. So now, what can we say here? What was the bottom line? So monitoring, filtering, and our job, and our tasks are two key activities. And say note, RPKI is useful and effective. But at this point, I would love to introduce the presentation of Tiziano Tofoni, as right after this analysis of incidents, let's try to understand what are the methods. So how do we mitigate such episodes? I can see you. Hello, Tiziano. Hi. Hello to you. Well, thank you so much for being with us. So hopefully you were listening already to what we said, of course. Now, my kind of conclusion is about monitoring, filtering, and RPKI, how useful that is. Leave you the floor. Thank you, Antonio. Thank you to my dear friend Antonio, as well as Alfredo Giordano, for the kind invite. And thank you to Mix for hosting this beautiful event, this beautiful conference today. I hope you can see my presentation. Unfortunately, I can only see my face for the time being.
Va bene. Allora, dunque, in questa brevissima presentazione cercherò.
Okay, I have a very short time to say what are the best way for us to prevent the root leaks and prefix hijacking that Luca introduced through two examples. So, but I can tell you that there are tens happening, perhaps on everyday basis or close to it. So these are incidents which are quite common in the world of internet. Now, before I actually go through the countermeasures, let me just go back to what Luca said at the end of his presentation. So this very small table here, and actually the source is for you to read, is from a book that is being published by Juniper Networks. Well, here the table shows you what are the key things that you're doing as you accept or reject BGP announces. And this is attached to the root leak. And these are regulations, rules, which are well known. There's also a formal classification, the RFC classification, saying exactly what a root leak is. This is, if you will, is a kind of a summary of what happens or what should happen. Let's say that I'm a provider. As a provider, I will receive an announcement from a provider with whom I have a peer agreement, for instance. If I take the second line of this table, so what I learn from a peer, then for me to send it over to customers, so I'm not sending that over to other peer, and I'm not sending to either upstream provider either. And there's a summary of rules here. And this is about the root leak. So what happens? So how can we prevent these leaks? Now, I'd love to call them the commandments that we go through. There's also Moses with the stone tables there. So the very first commandment that we'd recommend is to use routing policies all the time. And what's interesting here is really to mention the last RFC from last year, which has changed the way we behave in BGP. Announcement used to be propagated in a free manner. So let's say I do receive an announcement on a BGP, I do propagate it internally, and that happens automatically. Implementations of BGP have always been the same, up until there was a Cisco implementation that has actually adopted a different way. In the Cisco implementation, announcements are not are not accepted nor propagated. So, and that is important to say. And then RFC, a new RFC was in place in terms of default announcement. And you see what happens, iOS XR, default, XR, well, you will use command, and OS, then it's a full list of the implementations which are needed. And you may refer actually to this website. To this website, there's a link for you to click on if you want to find out more about this RFC 8212. And this makes it compulsory to adopt policies. So even if you want to propagate through an original BGP, well, let's say that you are also adopting that very policy and you're saying, okay, welcome to all. And that is the first commandment. Second commandment, here I'm drawing inspiration from Lenin statement. He used to say, study, 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 and that was happening in Moscow. For us to prevent root leaks, we should filter, filter, and filter once more. Of course, when we say filter, they have to be very well made, very well accomplished. So let's go through some best practices to see how do I use filters. Normally, a provider will receive announcement either from customers, that can be other providers, that I'm allowing them to use transit, or else I may receive announcement from peering in the inter-exchange points, and then I may receive announcements from other upstream providers. So what we recommend is to label this announcement. And how do we do it? Well, in the BGP world, we would use the BGP communities. You may choose the type you like the most. Recently, we have introduced something new, and then it depends whether your devices allow that. So we have recently introduced a 12-byte large community. We started from 4, and then we're now up to 12. So we've recently introduced this large community, BGP communities. And you may choose either one. It doesn't really make any big difference. But if you use the large, perhaps it provides you with extra freedom in terms of tagging. Now, there's a small example here for you to look at. And there's a small table in the below left-hand side corner. So any announcement I receive from customers, either providers or peering and so on, I do describe it. And then I do use a large community, well, in this case, but it's not necessary. So the first step in the best practice is to kind of assign a tag to this announcement, so you label it. So based on the announcement, you can apply your policies. The second step is to filter such announcement. Now, filters, and again, I'm providing an example here taken from Cisco. Because I have tagged those announcements coming from customers, and it's called AS 65536. So this is the large community that I have adopted to tag announcement from customers. I will apply an outbound filter towards my upstream provider, for instance, with whom I have a peering agreements in place, so that I will allow only routes of customers to go, to pass. Why there's no drop? Well, because the drop is implicit. So it is different, of course, if you need to specify it, but that it depends upon the structure that you use in the operating system you have available in Cisco, and that is a traditional syntax from Cisco. There is an implicit embedded drop, so this is why you don't see any here. Basically, what happens here, towards the upstream provider, I'm only allowing route of my customers to pass, to transit. And that was best practice number one. On customers' routes, here, there's an important aspect to mention. If it's well made, well managed, this would actually fix many of routing, leaking, as well as prefix hijacking problems. Perhaps I will go back on the second one in a moment. But let's say that my third commandment here is that we shall filter announcement from our customers, and we shall only welcome prefix that customers can announce. And actually, we might even automate these filters, this prefix, so that we can somehow, we make it mandatory to the customers to announce only what he can announce. What is it that he can announce? Well, it can be anything that he has received, everything that has been recorded in all RR, for instance. There's a small example here where customer eggs has two prefixes here. And I am filtering from customer eggs that I will welcome, I will accept only those that have been tagged appropriately. So the customer will never be able to announce anything that is not coming, that is not originating from him. Well, because, of course, there might be other prefixes that the customer might receive. Now, it would be nice if we could actually automate new prefixes to be added. So we kind of create a full list of new prefix. And there's some interesting tools that we might use, the BGPQ3 or the IRRPT. Now, if you want to improve at all this way of working, you can also allow your customer to submit some subnet. The one thing that I would recommend here is to accept, for instance, I'm now accepting subnet /25/25 and /24 from the customer. But again, one piece of advice here is to add a community, perhaps the no export. This is one standard BGP community that prevents these subnets to kind of go around the internet. And so what circulate are only those announcements that you have decided that you will accept. So this is to allow some smart engineering. Now, just by quickly mentioning these few rules for filtering, which I hope you're all applying today already, well, this is already reducing, cutting down the dangers, the risks that Luca has mentioned. Tiziano, sorry if I interrupt you. This is Antonio. Can you speed up a bit as we're lagging behind with our timings? Of course, I'm about to draw conclusions. There's one last commandment. It is unlikely that your customer will perhaps allow transit for a tier 1. So you might actually coming to the fourth commandment, the RPKI. Well, you all know what it is, and I don't need to explain the way it works. This should be applied. What strikes me is that in Italy, many of the providers, small, medium-sized, they implement successfully RPKI. If I take a look at large providers, there's no large provider in Italy that has implemented RPKI. Now, worldwide, all large providers are implementing it, so hopefully also Italian large providers will soon finalize it, will soon implement it. Otherwise, we always end up being considered as the non-implementers. RPKI only validates the origin, so perhaps the potential interesting future, a potential new.
Non ancora, diciamo,
A potential new regulation might be implemented, which is the BGP-SEC protocol specification. And this is indeed very interesting that there's something else to come next. So I've been asked to cut short. Now, by paraphrasing a real prince around this topic, unfortunately, I was given very little time. My piece of advice is that you have a big friend who's available to you, and then it's months, MAN RS. So I will invite you all to subscribe and become MANS compliant, because there's some good, common, and sensible rules to stick to. And I conclude here. Thank you so much.
Thank
you, Tiziano. Good job. Thank you so much for your practical advice, because at the end of the day, this is what we do. You have focused on more themes, and maybe if we have time, we'll come back to them during our very short panel at the end of this session. If I may have our guest on screen. Tiziano talked about RFC 8265. He is one of the authors. Not only that, though. So I'd like to introduce to you, connected from Washington, Kotikalapudi Sriram.
Sriram. So I'm very glad you accepted our invite to be here tonight. We just talked about some routing incidents, then about some mitigations and best practices. Now, with you, we are going to have a look to the emerging technology. So the floor is yours.
Thank you. Antonio, do we still have about 12 minutes for my talk?
I'm just asking to our director. Abbiamo le sue slide. Here are your slides. Okay, perfect.
Okay, thank you. Hello, everyone. Good afternoon there in Italy, and good morning here in the US, New York. Thank you very much, Antonio, for the nice introduction. I'm honored to be here with you. Thank you for the invitation. So I will focus on BGP route leak prevention and mitigation, specifically the IETF standards efforts today. So I wanted to mention a few things about the current or ongoing NIST efforts, BGP security guidance, NIST RPKI monitor, and the NIST BGP SRX, which is a suite of implementations in Quagga regarding for the route origin validation, BGP-sec path validation, and also ASPA route leak protection. So we'll take a closer look at route leaks. Just want to briefly mention about this security guidance document that we published almost 2 years ago. It provides detailed descriptions of technologies and standards relevant to BGP security and DDoS mitigation, and it complements the Manners initiative, which primarily focuses on implementation guidance and document. There are a number of topics that have been covered in this document. You can take a look at it when you have some time. I'll skip over that in the interest of time. I will also just take 30 seconds to mention the NIST RPKI monitor. We released a monitor 2.0 in April of this year. Many of you, or some of you, I'm sure, have been using it. And it provides you a variety of statistics related to RPKI and ROA adoption and deployment. And it also provides you the validation if you were to do the validation at a router based on RPKI. It provides you a variety of statistics related to the validation, and you can dig down and discover many details. So moving on to the route leaks topic, I'm thankful that Luca and Tiziano have already spoken about route leaks. They have introduced the topic, and they have also mentioned some possible solution techniques based on BGP communities. So here what I'm going to do is, I can skip this slide because this is about the introduction to route leaks. So in terms of the IETF specifications, there are three, we can put the three efforts in three different categories: short-term, medium-term, and long-term. The short-term and medium-term solutions are pretty much similar. Short-term uses a transitive BGP community, a large community. It's called a down-only, and it can be implemented quickly if the operator can incorporate it into the policy. It solves the problem of accidental leaks. Similarly, the approach, medium-term approach using BGP attribute is called only to customer, and it can be incorporated into code that is shipped with commercial routers, so it takes a little longer. And again, this addresses the accidental leaks, route leaks. The long-term solution is based on a new RPKI object called Autonomous System Provider Authorization. It will take some time because ASPA has to be adopted by operators, and the solution is generally good against malicious leaks also. So jumping into the solution, describing the solutions, Tiziano has already talked about the approach using community. So essentially, we are standardizing it, and this standard not only will solve the route leak prevention problem within an autonomous system, but also it will solve the problem of route leaks across autonomous system. So in this example, you see that the route propagates on the left side from AS5's customer cone, and it reaches into AS1's customer cone, and the AS1's customer AS6 leaks it to AS2. So at AS5, the first time the route starts to go to a customer or a peer, the OTC, only to customer attribute, is added. That indicates that subsequently the route should only propagate down. So in this case, AS6 propagates it up towards a provider, and that's a leak, and AS2 can detect the leak because there is the presence of OTC in the update. The OTC value is set equal to the AS number, which is setting it, in this case, AS5. So that is how the general principle of how route leak is detected and mitigated. AS2 will drop it and stop it from propagating. So some details regarding this. So that is a description at a high level. The details are in the document IETF draft. I've copied here the Ingress and Egress policies, which one can carefully look at and see that it really works both for mitigation within an autonomous system and also externally. An AS further down in the path can detect if there was a leak in the path somewhere. So now moving on to another method called ASPA, Autonomous System Provider Authorization. The ASPA is created by every AS in the internet, or expected to. And the AS, like in this case, customer I, can create an ASPA in which they provide information regarding their transit providers, ASJ, ASK, and ASM. All the routers in the internet will download this ASPA object, just like they download ROA today for route origin validation. So similarly, ASPA is downloaded by all the routers. The tier ones also create an ASPA, but they don't have transit providers, so they simply put an AS0 in the transit provider position. These ASPAs are registered in RPKI repositories. So once you have the ASPA, the method for detecting route leaks, I will briefly describe it. We define a hop check function. It's called G here. So it essentially tells you if you have ASI and ASJ consecutive ASs in the path, is that hop a provider or not a provider, a tested provider or not a provider according to the ASPA. And also, if there is no ASPA from I to J, for I, it is no attestation is available. So if it's a provider, it's an uplink. If it is not provider, it's a down or lateral. And if it is NA, no attestation, then it could be up, down, or lateral. So depending on the value of the hop check function at each hop, we can determine the validation of both upstream paths and downstream paths. For the upstream path, see in this case, the validating AS is receiving from a peer or a customer, so it is propagating in the upstream direction. We call it upstream path. If each hop is a provider according to the ASPAs, then the update is valid. If at least one of them is not provider, it's invalid. Valid means it's not a route leak. Invalid means it's a route leak. And if there are some no ASPAs for some of the ASs in the path, then the validation result is unknown, which means that it may or may not be a route leak. So once there is 100% adoption, then there will be no unknowns. There will be only valid or invalid, meaning it's route leak or not route leak. We'll be able to tell that. Similarly, we also have a separate algorithm for the downstream AS path. In this case, the validating AS is receiving the update from a customer. And essentially what we do is we have what we call a KL representation of the downstream AS path. On the left side, using the ASPAs for each hop, we identify a up ramp 1, 2, 3, and we set K equal to 3. And on the right side, we identify a down ramp from 6 to 9. We set L equal to 6. In the middle, so on the left and on the right, there was a specific ASPA which is telling us if the next hop is a provider or not. But in the middle, on the left and the right, we definitely know we have up ramp and down ramp, so consecutive providers. But in the middle, we are not either it's not a provider or there is no attestation. So from 3 to 6 depends on how that plays out. So if you have only the validity of the total route, the entire route, depends on the validity of the segment in the middle from 3 to 6. If that is 0 hops or one single hop, then it is a perfect inverted V or a V with a horizontal 1 hop at the top, and that is valid. And in the middle, if you have 2 or 3 hops, and there are 2 hops that are facing each other and each of them is not provider, it is invalid. Otherwise, the path is valid. So essentially, again, once again, like in the upstream case, we can have route leak if it is valid. Invalid means valid means no route leak. Invalid means route leak, and unknown means some ASPAs are missing. So in order to accurately design this algorithm, we were able to prove 2 theorems. These theorems are helpful for the design. I will not go into the details, but the general principles are what I just explained. And using these theorems, we are able to lay out an algorithm for the downstream AS path validation. It is crisply described here, but in the draft, it will be described in more detail. So this algorithm refinement happened only a few months back, and it has been accepted by the CyderOps working group. It will be incorporated into the next version of the draft. So the references related to these are listed here. Thank you very much for your attention.
Thank you, Sriram. Thank you for your on this ASPA mainly, but our streaming director just said me that we have no time for the scheduled panel, but just a comment from you. Again, Sriram on the screen, please. About time, there is an RFC that says that from idea to RFC, there are 3 years for developing, etc. So, what is your forecast about ASPA? Because we are in late with RPKI. There are no in the wild implementation on BGPSec. So, what about ASPA? Very timely.
Yeah, Alexander, I've been working with him, Alexander Asimov, on ASPA. So he, if you ask him, I think he will tell you several years, maybe 5 years or more, I think. So that is why we have the short-term and the medium-term solutions to get something going in between.
Thank you, Sriram. Thank you. Bye.
Thank you so much.
Thank you.
Bye.
Okay, grazie.
Okay, thank you to the last speaker of this session, since we have no time for a further session. Goodbye. Anyway, I am willing to collect any questions, and I can ask these questions to our speakers. So thank you so much for your attention.